Welcome! Today we'll explore a comprehensive PKCE testing framework that covers everything from browser DevTools analysis to automated security testing. Whether you're a security engineer, developer, or DevOps professional, this framework will help you identify vulnerabilities before they become breaches. Before we jump into testing, let's quickly understand what PKCE solves. Proof Key for Code Exchange, or PKCE, was created to secure OAuth 2.0 authorization code flows for public clients, especially single-page applications that can't securely store client secrets. Traditional OAuth flows are vulnerable to authorization code interception attacks. An attacker can steal your authorization code and exchange it for tokens. PKCE prevents this by requiring a dynamically generated code verifier that only the legitimate client possesses. Our comprehensive testing framework covers 28 test cases across 5 critical areas. We'll use browser DevTools, API testing, JMeter for performance, OWASP ZAP for security scanning, and specialized client-side testing. Let's start with what every developer has access to, browser DevTools. These 6 tests are your first line of defense and can catch critical misconfigurations immediately. Test PKCE001, Authorization Code Flow Validation. Open your DevTools, trigger a login, and inspect the /authorize request. You should see response_type =sign code, not response_type =sign token or ID_token. If you see token or ID_token, you're using an insecure implicit flow. PKCE002, PKCS 256 parameter verification. In that same /authorize request, look for code_challenge and code_challenge_method =sign S256. If these are missing, PKCE isn't implemented. If method is plain, you're vulnerable to downgrade attacks. PKCE003 is crucial. Search all front-end requests for client_secret. If you find it anywhere, you have a critical security vulnerability. Public clients must never expose secrets in front-end code. Moving to API security. These tests ensure your JWT tokens and API endpoints are properly protected. Let's look at the most critical vulnerabilities. PKCE007, JWT signature integrity. Take a valid JWT token, modify just one character in the payload, and try calling your API. The server should immediately reject it with a 401. If your API accepts tampered tokens, you have a critical security flaw. PKCE008 tests audience claim enforcement. Try sending a valid token to the wrong API or service. The odd claim should prevent cross-service token abuse. If it works, attackers could use tokens intended for one service on another. PKCE009. Call a privileged endpoint without the required scope. Your API should return 403 with insufficient _scope. This prevents privilege escalation attacks where attackers try to access resources beyond their authorization. Always test expired tokens, PKCE010, and token revocation compliance, PKCE028. Expired tokens should be rejected immediately, and revoked tokens should fail all subsequent API calls. Performance testing isn't just about speed, it reveals security issues under load. JMeter helps us test PKCE behavior with concurrent users. PKCE011. Run multiple concurrent authorization flows and verify every code_verifier is unique. Duplicate verifiers are a serious vulnerability. They could allow session fixation attacks. PKCE012 checks token lifetime policies under load. Extract the XP claim from multiple tokens and verify they're all short-lived, ideally 60 minutes or less. Long-lived tokens increase attack windows. PKCE013 tests refresh token rotation. Exchange a refresh token for new tokens, then try using the old refresh token again. It should be invalid. This prevents token reuse attacks. OWASP ZAP automates vulnerability discovery in your PKCE implementation. These tests simulate real attacker scenarios. PKCE015 is the big one. Authorization code replay attacks. ZAP intercepts your authorization code and tries replaying it without the code_verifier. If tokens are issued, PKCE isn't properly implemented. PKCE016 tests downgrade prevention. ZAP changes code_challenge_method from S256 to plain. The server should reject plain method. If it accepts it, attackers can bypass PKCE's cryptographic protection. PKCE017 injects malicious payloads into state and redirect_URI parameters. Look for XSS vulnerabilities, open redirects, or parameter pollution attacks. PKCE 018, force HTTP requests or mixed content scenarios. HTTPS should be strictly enforced with HSTS headers. Any HTTP acceptance is a critical vulnerability. Client-side security is often overlooked but critical for PKCE effectiveness. PKCE 022, the code_verifier should never touch local storage or session storage. Check your application storage. If you see PKCE values persisted, they're vulnerable to XSS attacks. PKCE 023 tests post-flow cleanup. After successful authentication, all temporary PKCE values should be cleared from memory. Lingering values can be exploited by malicious scripts. PKCE 024, force network errors and server failures. Error messages should be user-friendly without exposing sensitive technical details. Check console logs for accidental data leakage. Server-side testing ensures your identity provider and API gateway configurations are secure. PKCE 026, verify your SPA client registration. It should only allow authorization code flow with PKCE. No implicit flow, no client credentials. Misconfigured clients bypass all PKCE protections. PKCE 021, audit server logs for sensitive data exposure. Authorization codes, tokens, code_verifiers, and client secrets should never appear in logs. This is often overlooked but creates serious audit trails for attackers. To implement this framework effectively, start by integrating the tests into your CI/CD pipeline. Automate API testing, run ZAP in daemon mode, and set up alerts to catch critical failures early. Prioritize P1 tests first, since they target the most critical security vulnerabilities. Once those are covered, move on to P2 tests, which help strengthen your security posture but don't pose immediate risks. Leverage each tool for its strengths. Use DevTools for quick, real-time feedback, JMeter for API and load testing, ZAP for automated security scans, and custom scripts to validate client-side behavior. If this framework helped you understand PKCE security testing, smash that like button and subscribe for more security content.